You're a native of Chautauqua County. Give us a little bit of your background.
I'm a native of Chautauqua County, that's right. So I always have to go to Neckers Company in Clymer to get maple syrup and maple cream and see my old cousin, Boo Neckers, whose first name is Harold, and talk about the gossip in Clymer, which is quite abundant. And I was there today, and I happened to go to the Clymer restaurant for breakfast and saw all my old high school friends. But I'm from Clymer. I grew up in Clymer. My folks brought property, and I'm delighted to see so many Lighthouse Point residents, alumni, friends, whatever here. My folks bought property on Lighthouse Point about 1950. Where's Ken Aldrich? Where's Sue Aldrich? You remember when it was? About 1950, right? 51, something like that. And so they lived there until my dad had to finally sell. He lived to be 97, and I think we convinced him to sell the property in about 2 years before that. Joan Smith was the name. Well, Joan wasn't, but all her kids were, and her father and mother were neighbors at Lighthouse Point. So I go back a long way with that part of the world. But my wife was from Bemis Point, so I spent more quarters on the Chautauqua Ferry than I like to admit when it ran, and that was only from May to what? November? I've forgotten. But anyway, so I had to go across the ferry, and my wife's father was the last chair of the Board of Supervisors in Chautauqua County, Dick Evans. And back in the old days when we had a town supervisors group, which was called the Board of Supervisors, now we have a legislature. And there's a difference between Senate and House, and you can figure that out for yourself. But the bottom line is that Dick Evans was the last chair of the County Board of Supervisors. And so things that got started and certainly were completed during his tenure were the sewers on the east side of the lake and the bridge. Chautauqua Institution would be a very different place if it wasn't for the bridge right now. So I'm very proud of what he managed, and of course we now own the property that his father-in-law and uncle, I guess uncle-in-law is what it would be, built 2 houses at 104 and 106 Lakeside Drive, or 134 and 136 Lakeside Drive in Bemis. So my connection with Bowling Green was long-standing. I moved there a long time ago, back when they had a hockey team, which they didn't for a while. Now they got another one, and better now. And so we began something called there the Center for Photochemical Sciences, and this was in 1984 or 1985. And what this center was to do was to deal with the interaction of light with matter. And what we anticipated, we didn't know this, but what happened was we were sort of anticipatory for the demise of silver halide photography. And that really is what pushed the people from our center, that and three-dimensional imaging, stereolithography, things of that sort, pushed the products of that as students out into the commercial community. And one of the very first members of a department other than chemistry in the Center for Photochemical Sciences was Professor George Bullerjahn. George was a faculty member of the Biological Sciences who studied bacterial chlorophyll. I never can say those words together. Bacterial chlorophyll. And of course, this is light with green stuff, green-blue stuff, and that was his professional expertise. So he became immediately a PhD mentor of the students that came from all over the world to study the interaction of light with matter. And so it's a delight for me to see him evolve his professional interests into studies of green algae in Lake Erie. Why is that a problem? Well, my water comes from Toledo. And 4 or 5 years ago in the summer, I didn't have any water because the green algae with the microcystins made toxic products into the water supply in Toledo, and we were without water, had to boil it for what, about 2 weeks, close to it.
You weren't supposed to boil it, actually.
Oh, I wasn't.
That made it worse.
I can only report what the newspapers say.
Oh, yeah,
Anyway.
it was the blade.
Those photochemists.
No, it was not. It was the Blade. It was the Pittsburgh Post-Gazette for anybody that knows the Block family. But anyway, Anyway, so Professor Bullerjahn, what did you correct me for? I forgot.
Yeah.
Anyway.
Dog boil, dog boil.
Oh, well, was my colleague in biological sciences, and then he began talking and working with a group that was studying the toxic algae blooms in Lake Erie, which are a dramatically difficult problem, okay? And so I encouraged George to talk to the Toledo Rotary, which he did, and out of that, we developed now a non-photochemical interaction. It was just a professional interaction. And I live on Chautauqua Lake, and one thing led to another. So Professor Bullerjahn is our guest tonight.
So George, just so everybody knows, you really were a Boston Red Sox fan?
That is correct.
And now that you live in the Bowling Green area, which is near Detroit, have you kind of changed allegiances?
My number one team still is the Red Sox, so I grew up right in the middle of Boston. Okay, I didn't learn to drive till I was 22, so I could walk to Fenway, so I have to be a Red Sox fan. But my number two team, and I'm not sucking up to you, my number two team
It's important, yeah.
in the American League was always the Detroit Tigers, because they have every bit of the history of the Red Sox with none of the drama. And so I think it's a lot easier to be a Tigers fan many years than it is to be a Red Sox fan.
Yeah, and I just, because I know you were driving here from Toledo, probably didn't listen to ESPN on the way up, but it was the Tigers 7, Red Sox 3 today, just in case you're curious.
Yeah, and that first game of a doubleheader. We're waiting on the second one.
So, George, give us your best Doug Neckers story. Doug's was a Bowling Green. He was an institution, and give me your best shot.
That is the best Doug Neckers story. I can't. That's really putting me in the spot.
Well, that's precisely the right reason.
Okay. I will have to pass on that, because Doug has done a lot of. Doug was a tremendous help to me. I came to Bowling Green in 1988, and I was in the Department of Biological Sciences as a graduate faculty member, capable of mentoring PhD students. But Doug, through his efforts, made connections with Russian universities after the collapse of the Soviet Union, and brought over incredibly talented Russian students that I mentored through the Center for Photochemical Sciences, and that have done extremely well. And most of them have stayed in this country, working in the pharmaceutical industry. And so, can I come up with something funny? I will eventually, but I just owe Doug a lot for getting my career off to a good start.
Perfect. We look forward to that funny story. You're a microbiologist. How does one kind of become a microbiologist? Give us your career arc.
Okay, I'll give you my career arc. The way I describe it to a freshman in a microbiology class is that I care about the organisms that drive all life on Earth. And so the way I say, and this will sound glib, is that if all, and I like cats, okay, but if all of a sudden all the cats were wiped off the face of the earth tomorrow, life would go on. There might be some, more rodents or something. The food webs would change a little bit, but life on Earth would be pretty much unchanged. If all the microbes were to be wiped off the face of the earth, all life would die in a couple months, because they are absolutely critical in cycling all the elements out of the Earth's crust and atmosphere on which all other things depend. So that's why I'm a microbiologist. They're the most important biomass on Earth. That's my bias.
So you went to Dartmouth?
That's correct.
And then from where'd you go?
I got my PhD at the University of Virginia in the Department of Biology. Then I was a NIH postdoctoral fellow at the University of Missouri. And then I sort of came a little bit further east when I started at Bowling Green in 1988.
You're specializing in this toxic bloom-forming algal bloom stuff. Pronounce it correctly.
Oh, okay, so the organisms that I've studied for 35 years now are called cyanobacteria. And just providing a little bit of the career arc, I was studying cyanobacteria many, many years ago when I started working with Doug, just trying to understand them as photosynthetic organisms. If you want to study photosynthesis, you can study plants, but those are harder to grow. If you can just grow a bottle of cyanobacteria, they do plant-type photosynthesis, and you can just do experiments on photosynthesis in the lab. And over the years, though, it's become their importance on Earth has become people have been increasingly aware of just how important they are on Earth, because in the intervening years from the starting to now, we know that cyanobacteria produce about a quarter of the oxygen in the atmosphere. They are absolutely critical to the health of our oceans. But there are a few bad guys out there that cause these toxic problems. And so I've kind of went from being a lab scientist to then understanding how these organisms behave in nature. And since Lake Erie has been plagued with toxic cyanobacteria, it was a natural transition for me, knowing something about these organisms to seeing how we might solve problems that these organisms cause.
Doug, you live in Bemis Point. You are involved. I think you're on the board of the Chautauqua Lake Partnership. How did you get engaged in that process?
I'm not on the board of the Chautauqua Lake Partnership. I'm not on any boards at this stage, I don't think. I tried hard to not be. But anyway, I think I got engaged. I don't really know. But I became impressed with what I thought were scientific approaches to Chautauqua Lake's problems. We've had a lot of problems in Chautauqua Lake. I got up this morning, my house is 35 feet from Bemis Bay, and I looked out over that expanse of maybe 2 miles of Chautauqua Lake, and I thought, where in the world could one see this other than right here? And my experience at Lighthouse Point as a boy was very much the same. And my experience at Chautauqua Institution, my mother would bring me to the gate and I'd give them a quarter and go in and hear the symphony that night when I was in high school. So the bottom line is that the Chautauqua Lake and the Chautauqua region and everything that relates to everything that we all are here is part of my DNA. And so I got involved with the Chautauqua Lake Partnership when I started to hear some scientific approaches to incredibly difficult solutions, incredibly difficult problems that were in search of solutions. Now, it doesn't pass anybody's observation that the leadership has a PhD biologist, an engineer, a professional engineer, an orthopedic surgeon or a cardiac surgeon. These are highly educated people who are using their skills to treat the problems of Chautauqua Lake. And I get involved only when I really think that the things that are being done are going to make a difference. So the answer how I got involved was I saw some people I thought were doing things differently that were going to make a difference, and that's my cup of tea.
And based on that analysis, you're the one that reached out to George and his group in Bowling Green. What precipitated that? Why bring them in?
Well, among other things, I was without water at my house for some number of days. And that's, you can live without food, but living without water is a pretty serious problem. So that got my attention, and then I started to see the names of the people who were scientists who were dealing with the problem in my immediate area. And that was, among others, Professor George Bullerjahn at Bowling Green. So I'm sure I contacted George when the Toledo Rotary was going to have a panel discussion on, quote, water, unquote. He said, well, really, if you're going to have a politician and you're going to have a newspaper editor and you're going to have this and that and the other thing, don't you think you ought to have one scientist in your panel? Now that's how George got involved. And then we didn't really see each other for a while. And then I started to see things about the Lake Erie Center for Clean Water and Human Health. And then the creme de creme for a scientist and a community of scientists in higher education is to get a National Science Foundation Center of Excellence. And George and his colleagues, George being the principal investigator, got major funding about 6 months ago from the National Science Foundation and the National Institute of Environmental Health for a center involving 8 research units, 7 plus George, ranging from Syracuse on the east to Michigan, NOAA, the University of Toledo, the Ohio State University, and several others on the west. That gets my attention, okay? And so George and I began talking about Chautauqua Lake. This is an encircled lake. There's not, it's not Lake Erie. It's a circle that's got some potential for solutions. The problems that are coming here are the problems that we've seen in Lake Erie for quite a while. So the question is, what do we do about it? And so for that kind of a solution, or at least a deal with the problem as we see it, I look to the scientific community. Professor Bullerjahn being a strong leader in the field that we absolutely need here. Scientific study to prevent, or at least remediate, toxic algae blooms in Chautauqua Lake.
So, George, I can see why you're not going to come up with a funny story with that wonderful lead-in and all this. You are the head of the Lake Erie Center for Freshwater and Human Health and received a $5.2 million National Science Foundation funding for, I think, a 5-year period. Could you explain a little bit about that, what the mission is?
Yeah, so basically what this does is we've had a lot of collaborators over a number of years that have been studying issues in Lake Erie centered around harmful algal blooms. And we collaborate with a lot of folks, and we decided to get together and apply for this special program called it's an NIH NSF program called Oceans and Human Health. And then NSF views the Great Lakes as oceans. I don't make the rules, those are what they are. So we applied, and there was really political will to do something. The Toledo water crisis was a national disgrace. People knew about it. And so they funded us for $5.2 million to run 3 research projects that give all our collaborators, and about half the money stays at Bowling Green, and about half it goes as subawards to the other institutions. And what it's done is it's given all the folks we collaborate with a whole lot more resources to do what we've already been doing. And to describe the different kinds of projects we do, there are actually 3 research projects that were approved. One is to understand the environmental drivers for different bloom types. There are lots of different toxic cyanobacteria that can harm water supplies wherever you are, but different kinds of environmental conditions are required to yield different bloom types. And project 1 is to figure that out. Project 2 is to assess and really dive deeply into the genetics of all the different toxic cyanobacteria we can find, just to identify, have we actually identified all the toxic substances that these organisms make? The answer is no. What really are the new threats which may be emerging? And then the 3rd project is very highly applied and basically assesses the technologies which are necessary to either to detect the blooms, detect the toxins, and then inform the public about those threats. And with respect to Chautauqua Lake, the reason, in addition to Doug just being Doug and we're friends,
That's what.
By the way, enough said.
Right. Chautauqua Lake affords an opportunity to test some things that we might later then translate to a much larger system like Lake Erie. And so what I've proposed to the partnership, and I'm grateful that they've been able to provide $50,000 of support, is to deploy sensors to look at nutrient loading in the lake. There's studies that have shown that phosphorus is being released from internal loading from the bottom of the lake. And if we can measure the rates of that, that can inform management strategies down the road. And there are sites in nearshore Lake Erie which exhibit very similar features to Chautauqua Lake. And what we learn here can inform management strategies in our primary site. which is the lower Great Lakes and Lake Erie.
So you're talking a little bit about a pilot program using some of your techniques on the Great Lakes, Lake Erie, and try that here. Are you thinking of test? There used to be a test ground for your equipment, a test ground for some.
It's a test ground for equipment. It's a test ground for trying to understand rates of nutrient loading and nutrients driving these events. If we can measure that in a small system, then we'll get a handle on really what it's going to take to measure these sorts of events in a larger system.
How does it work? Is it a buoy that sits there and you just sort of...
What it is, I actually deployed a very similar device of this type yesterday in Sandusky Bay, just in the southern part of Lake Erie. What it is, it's a device that brings in water, does a chemical reaction that yields a color reaction, and that color yields a chemical reaction with the phosphorus, yielding a color reaction, and a detector is able to figure out how much phosphorus is released in the water based on that chemical reaction. So these are devices which are suspended in the water and are basically a robot which brings in water and measures phosphorus content in the water using wet chemistry.
Is the goal, if they had a number of those devices, to find certain hot spots? Is that the deal?
Yeah, the deal is to deploy a number of these and then move them around and identify what the site's producing the most phosphorus is, and that could perhaps lead to remediation strategies like dredging down the road.
Part of that is just establishing a strategy. Recently, with a lot of publicity, various stakeholders of Chautauqua Lake, including the Chautauqua Lake Partnership, have been involved and have signed something called a Memorandum of Agreement, which deals with the management of invasive weed growth.
Yeah.
That's the weed growth aspect of it, and you'll be doing kind of the algal bloom. Where do the two intersect?
Well, really, my understanding is a Memorandum of Agreement really is based on weeds. The weed control, and then really that's not my angle. My angle is there's weed residue, there's organic matter which has been accumulating over the years, and from these anaerobic or oxygen-free sediments, phosphorus is being continuously released. And so the weed control is one issue. I think what I'm proposing is really the only project looking at nutrient levels and nutrient fluxes and nutrient management within the lake itself. And so I think they do intersect, because ultimately the weeds are a source of phosphorus if there's weed residue decaying at the bottom of the lake. But I just want to know where the hot spots are for phosphorus release, so those could be remediated later. And again, what I want people to view is that what our center does is provide resources. We have the expertise, and we're developing the expertise to deploy these sensors and devices. We can take water samples and measure nutrient levels, but it's what I'm looking at here are the experts on the Chautauqua Lake, because I'm not from here. So what I would like to do is generate the data that will inform decisions that the community collectively makes.
And an important part of this is that one of the resources that Professor Bullerjahn and his colleagues bring to the table is graduate student and undergraduate student research scientists who will be part of the execution of this pilot project. And the pilot project has as a goal substantial increases for the future study of other parts of Chautauqua Lake. But in order to do that, Professor Bullerjahn has to find out, he has to set some of the guidelines, set some of the rules, and that's what the pilot project funded by the Chautauqua Lake Partnership is all about. And next year, hopefully there will be major support from other agencies that'll bring not only sensors, but students and income to the area for the lake's problems. We don't know anything about weeds. That's Jim's problem. What we know about is green stuff.
And to Doug's point, I'm dedicating a graduate student to the project this summer. He's a new graduate student. He doesn't know this yet, but yeah, he chose me to work with. He's coming from Virginia, so this is the project he's going to be doing, and because he's aware that we're looking at nutrient loadings. He just didn't know it's going to be here. So, but that's it's going to be great. Another good resource that our center provides is that one member of the center is from SUNY ESF, is Greg Boyer, who's the leading toxin.
Syracuse.
SUNY ESF Syracuse. He's the leading analytical chemist for cyanobacterial toxins in the world. And so he's worked with us. All the analytical work that is necessary to identify toxins is, he's basically will be doing for us. And he's local, and he's sort of our boots on the ground in New York that's keeping an eye on what potential RFPs or requests for proposals might be coming from the state. I know the state has set aside funds for harmful algal blooms, and Chautauqua Lake is a lake targeted for that program, but the RFP just hasn't been released yet. I should also mention another colleague at Bowling Green, Tim Davis, who visited in January. We drove up in a snowstorm, a beautiful snowstorm in January 10th, and met with the partnership. And Tim Davis we just hired him as a mid-career hire away from the NOAA Great Lakes Environmental Research Laboratory in Ann Arbor, he was the leading cyanobacterial microbiologist at NOAA.
National Oceanic and Atmospheric
Administration. Yeah. Yeah.
Right. Oceans and air.
Yeah. Right.
So, George, Doug was able to convince you to do that which you are planning to do, and are you currently doing some of this stuff in Lake Erie?
Yes, we do a lot of things in Lake Erie. If you go to the website habs.glos.us, habs.glos.us, you'll see that there's a network of buoys that are all through western Lake Erie that report data every 20 minutes to the internet pertaining to water quality. And so that has enabled the development of kind of large models for water flow, where the blooms are going. We're only now putting, for this bloom season, we have 2 of our 4 buoys in place, but NOAA hasn't put theirs out. I mean, it's early in the year. But there's a network of participating institutions which are taking regular measurements of water quality throughout the lake, western Lake Erie. We're also doing lots of, in addition to monitoring work, we do a lot of experimental work looking at factors which contribute to the growth of bloom biomass, growth of the algae, and then looking for factors which cause the bloom to crash and decline. And also trying to understand the factors that make a bloom more toxic or less toxic. And nutrient levels have a great deal of impact on that, great deal of effect. The amount of nitrogen in the system actually can be a very important driver for how much toxin they produce, because the toxin molecules have a lot of nitrogen in them. And so we're looking at nitrogen levels as a potential driver for toxicity, in addition to phosphorus being a major driver for biomass. We're looking at, I can list all sorts of things we're doing. If you look at a bloom, this is one of the things that people really find confusing, and I find it confusing also. If you look at a bloom, you see green scum on the water. Okay, you've seen the green scum? Oh, there you go, okay. That you would
Okay, for those who have forgotten,
you might...
That's front yard.
The confounding thing is that it might look, and if you look under the microscope, it's all these little green balls that look very similar to one another. So you might say that's all a perfect monoculture. They're all the same organism. Well, that's not really the case. It's a mixture of slightly different genotypes. Some produce toxins, others don't. You know, so, and trying to figure out the interplay between what drives particularly a bloom being more toxic is of great interest to people in Toledo who don't want poison in their drinking water. But certainly, all green scummy water is ugly and drives down property values, and that's a huge issue. We want to limit biomass, but also one of our interests is what are the factors driving toxicity?
You mentioned a bloom season.
Yeah.
What is there? What was that I mean?
Bloom season is when the water warms up and blooms like it hot. That's one of the, that was a editorial in Science magazine by Hans Perl, one of our collaborators. He's a Dutchman too. Okay.
Oh, yes, I forgot that.
Okay. Yeah, we actually, our ancestors came from the same village in the Netherlands, okay? You know, on the,
We found this out 35 years after we've been in college.
okay, anyway, yeah.
Not important.
But anyway, the blooms like it hot. Microcystis, which is, you know, pretty much is a very common toxic cyanobacteria. Its ideal growth temperatures are between 25 and 28 degrees Celsius. And so the summertime surface water is perfect for that. There are other cyanobacteria which are toxic, which will grow at slightly lower temperatures. And Planktothrix likes like 22 degrees, but bloom season is warm water, basically.
And not necessarily on the surface level, it could be subsurface level. I mean, because as you know, when you dive up in that, you get cold spots, hot spots, and like that.
And there are benthic or bottom-loving cyanobacteria as well. And I don't know whether there's been a survey of what's growing on the bottom, but in some areas, where there's some water clarity down to the bottom, you can have cyanobacteria, toxic cyanobacteria growing on the rocks in the bottom, and those produce actually a different suite of toxins than the ones we see in the water column.
Maybe this is for Doug. Doug, just because you're an observer of all things, do you have a thesis, a theory, before they start gathering data of what they may find and kind of just a guess?
Well, I didn't set that question up, but I was thinking about going in that direction. The situation is, I don't know what they're going to find, but I've heard reports from people that swim in the lake that there are toxic microcystins of various kinds there. Their dogs get sick and things of this sort. The thing that really interests me is that we can identify some of the molecular compositions that lead to this toxicity. And if we do that, then we as a group, all of us, will bring to bear in the scientific community information about the entire field of toxicity of microcystins and things of that sort. That will be of value to the world, not just to Chautauqua Lake. And to me, it's said publish or perish, but publish or perish means you have something to contribute to your greater community of potential scholars than just a little bit of experimental data. And so the goal that I know that George and his colleagues are working on is to try and identify some of the facets of the microcystins that will lead to various information about the genesis. He talked about the genetics of these toxic materials. So my goal is that he puts Chautauqua Lake on the scientific path of leading the world in studying these kinds of problems. It's a small lake, relatively speaking. Its problems are not that bad yet. And here is a world-class scientist who's willing to help us study those problems here.
George, do you have a working theory of what you and the data, when you have various buoys throughout, maybe at some point you have 10 buoys gathering data, what is it that you perceive you may find and report on in 5 years from now?
5 years, I would expect that we would have a model for where the phosphorus is coming from, and you know where most of the phosphorus is coming from, and be able to really have sort of a mass balance of, really how much phosphorus is stored in the sediments, how much is coming down the rivers, how much is being released per year. And then perhaps get a handle on, does this continue when the water cools off? When the water cools down, or is there, what drives phosphorus release from the sediments are microbial processes, the consumption of oxygen, and then when there's a consumption of oxygen, phosphorus, which is bound to, well, I don't want to get into the chemistry. Anyway, there's a lot of microbiology that goes on that results in release of phosphorus from anaerobic sediments when there's no oxygen present. And does that happen at a similar rate even in the winter? I'd like to know that. So we're looking at events. We're putting these out in the summertime when we know there's a lot of biological activity. But what's happening really year-round? Is there can we extend our models to predict how much phosphorus is coming out of the system in all seasons?
In 2015, Bowling Green held a workshop called Global Solutions to Regional Problems, collecting global expertise to address the problems of harmful algal blooms. And the topics included biology of bloom-forming species, which I think we've talked about, environmental factors underlying bloom formation, which you're studying, sensor development and bloom detection, which I assume are the buoys, remote sensing. I'm not sure, is that the same thing?
That's me looking at blooms using satellites, drones, things that can image the lake in using particular spectral detectors for different measuring the amount of chlorophyll and other pigments in the water to get a handle on the intensity of the biomass.
Another topic was prediction of blooms. And the one that I'm not in your world, I'm not of your world, the science world, but best practices for control and remediation. That's sort of once you gather all the data, all the information, you put it up on a whiteboard, and you say, here's what we found, this spot's hot spots, this is what we find. Then what do you do?
Yeah, so there are a number, depending on what the lake is, there are a number of different potential solutions. And for Lake Erie, where a lot of the phosphorus and nitrogen, and most of it's coming from agricultural runoff, which is really not that much of the case, which is not that big a contributor here. It's regulating or changing how farms are fertilized. You can apply new technologies to the injection of fertilizer into the soil. It's more expensive, but it uses less fertilizer and there's less excess nutrients to run off. So you can change land use practices in an agricultural area. Here, if based on based on prior data, most of the phosphorus is coming from the sediments. Well, targeting areas for having targeted dredging operations could be a solution. There are some lakes, Lake Balaton, Hungary, we've done some work on. They had horrible algal bloom problems. But what they did is they created an artificial wetland around the inflow river, which consumed excess nutrients before it entered the lake, and now the lake's clean again. And along the same lines, it was a beautiful solution. It cost a lot of money. The EU put in a lot of money to do this, and now Hungary doesn't like the EU, but that's another story. In creating this wetland, they made it a wonderful refuge for birds, and birders come from all over the world to go to this site they built just for the purpose of reducing nutrients coming into the lake. So it was absolutely a huge success story. So there are different prescriptions that you would write for each lake.
Doug, how's the flow of data going to come? So George, over the next few years, is going to be using heretofore unsuspecting intern to come here. We will not run the tape until you tell that person.
You can go ahead.
I lost your train of thought.
So how's the data flow go? Is it generally, are you working with the partnership, and then the partnership makes it available? Do you have a sense of that Maybe Doc, maybe.
Well, I think the situation is we gather the data, and once you gather the data, then that source to advise management about what to do about the problem. Now, if you find all sorts of phosphorus loading in Bemis Bay, which has a depth of whatever Jim can tell us, you deal with it differently than if you find it at the outlet down near Jamestown. So I think the data will tell us where the problems really are, and will advise management, whoever management will be, what to do with the problems when we have that information. You know, one of the things that I have to say this because anybody, I'm going to ask this question. This is a tempting.
Oh, we don't ask questions
All
here.
right, well, how many in here read the New York Times? Raise your hands, okay? You're all Chautauquans. You ought to all your hands. Anyway, how many saw the letter from Thomas Edison's great-grandchildren in the paper not too long ago? Not a soul? All right, well, we haven't treated this lake very well over its history, right? Off Chautauqua, we know that, and my friends at Lighthouse Point know for a fact that a lot of stuff went into the lake that shouldn't have gone into the lake 50 years ago, 60 years ago. And off Chautauqua, there were no sewers at Chautauqua until the turn of the 20th century, right? So what happened to the waste from U.S. Grant and John Hyle Vincent until 1900? I'll let you answer that question. I have my own answers that Greg does not like to hear. But so those questions, never mind. But the point is that we will have that history outlined for us in the information that he gets about the legacy weeds and other things that caused the problems that we now see.
But at the same time, I mean, we will be generating data. We have to come up with a mechanism by which the data are publicly available and shared by all. I mean, this is, you know, one good thing about, you know, basic research in science is that it's not, you know, it's not, there are no trade secrets here. You know, we're here to generate data. Certainly, as soon as we know what's going on, we share it with the partnership. We share it as broadly as we can. So, you know, we on our center website we do have, I mean, we have all sorts of data that are available for download. You know, this would be part of it. We'd share URLs with people to provide the information. So, you know, our job in our center, our mandate is to make data available. And so, can I picture in my mind's eye precisely what the mechanism is now that we're just starting? No, but we can post things to a website and give you a URL at the very outset. We'll share everything we find with the partnership, and the partnership can share that with the broader community.
Or with anybody else. This is not.
There's no secrets here.
Right. We don't. This is not a local thing at all. This is to solve Chautauqua Lake's problems about blue-green algae.
I mean, there's a lot of scientific research where you know, maybe you're aimed at designing a drug to do something. You know, that's trade secrets. You know, and you only publish a little bit of that. These, you know, I'm not going to be patenting anything. I'm just going to be providing information that people can use. That's my job.
Let me give you one addition to this. Lake Erie, the people, the I don't know what to call them, but the activists about Lake Erie and Toledo just put legislation in front of the, no, you're going to answer the question differently, but I want to add one point. Put legislation in front of the voters that gave Lake Erie citizens, gave Lake Erie a right to manage itself, right?
Yeah, that does.
Now,
yeah,
Lake
Erie has rights.
Right. Okay. So Lake Erie.
It's a standing issue. It's an incredible constitutional law
And
question.
these folks actually spoke to the UN yesterday.
Right. Okay. But let me go on. So Lake Erie has rights, and so Lake Erie can go to Joe Farmer and say, "Quit throwing that gunk in Lighthouse Point Creek, because it's getting into Lake Chautauqua." Okay. But the bottom line is Lake Erie has rights. You know who opposed it? With a large investment? BP Petroleum.
Oh, yeah.
$308,000 to oppose this little guy, Mike Ferner.
Yeah, right. So,
In Toledo, right? Now go ahead.
okay, all right, so
It is an interesting, bizarre question, but
okay,
go
so-
ahead, answer, Jay.
and I'm being interviewed here by a lawyer, so that's very interesting. So I'm not a lawyer, but I have some issues with this legislation or with the folks, what was put on the ballot. Where do we draw the line as to what has rights? Does my backyard have rights? You know, so can any item or any natural thing on the Earth's surface have rights?
Too philosophical.
Okay, all right. So I sort of, so where do you draw the line? And then so it seems to me all this legislation is doing will wind up paying a lot of lawyers a lot of money to argue about something we already know, is that there probably aren't rights that can be afforded to a thing on the Earth's surface. But anyway, so that's so. However, there is a legal path which I think is effective. We were asked, the Environmental Law Policy Center in Chicago, I'm talking about Lake Erie now, so not Chautauqua, but in the Environmental Law and Policy Center in Chicago sued the US EPA to come up with an impairment designation for the open waters of Lake Erie. And they had been reluctant to do that, and all you have to do is talk to a charter boat captain that has to power up his boat in order to get through an algal scum so his clients can go fishing. That sounds pretty impaired to me. Would you agree with that? You know, you need extra juice to get through this scum. So we were asked, a bunch of us from University of Toledo, Bowling Green, NOAA, and EPA Glenpoe in Chicago. We were put in a room and said, okay, we realize that there is this lawsuit. We realize we are going to have to come up with a means to declare the open waters of Lake Erie impaired. So can you, come up with an impairment designation metric, and then a metric by which we could delist it when things improve? And we did it. We came up with it, we published it. It's actually, we published this, it came out like a month ago in a journal. And that's the way to go. And since then, we now have this impairment designation that opens the door for TMDLs for the river. And that's led to another lawsuit for the Environmental Law and Policy Center to the EPA saying they're dragging their feet on this. That's the route that makes sense, because we actually have a metric by which we can say it's impaired, a metric by which we say it's improved and no longer listed. And that's the route that is following, I think, more traditional legal path. Oh, you're the lawyer, so maybe I shouldn't be interviewing the interviewee, but does that sound more like what law should be in this sort of thing?
You're right, you should not be interviewing the interviewer. Though standing is a big issue that Doug and I have chatted about before, and it's bizarre for me. Get back to Chautauqua Lake. When you were here with Tim Davis, George, at the encouragement of Doug, you actually put together sort of a slideshow, and we unfortunately don't work in the world of slideshows here, but proposed activities in Chautauqua Lake.
Yeah.
Do you want to kind of just go through, perhaps in the last few minutes that we have,
Sure.
kind of what that would be?
Okay, so what we initially proposed, and we were thinking that the statewide RFP would be coming out and we'd be able to apply for a full suite of funds that will enable us to do what, the big plan. We were proposing acquiring 6 phosphorus sensors that could be suspended from buoys, moved around every few weeks so that we could identify hotspots. At the same time, Professor Wigdall Perry had shown that there's, from some experiments, that there was a depletion of nitrogen in the waters, and that the blooms seem to, later in the year, respond to nitrogen amendments. So we were going to deploy a couple nitrogen sensors to check rates of denitrification, which may tell us a little bit about the overall nutrient balance in the waters. These nitrate sensors are very, very easy to use but ridiculously expensive, so we couldn't afford more than 2 of them. So the idea was to create create a detailed survey, mostly focusing on the southern part of the lake where the issues are likely, my understanding is more severe, and then identify nutrient fluxes that could inform subsequent remediation strategies.
And you get is part of the funding for that, you're seeking kind of local funding for that, and then in addition, perhaps state, once they get their RFP out?
Well, yeah, really the bulk of it was going to be from the state. We're looking at state funding for this. Now, what we would also be hoping for in kind would be the assistance from local residents and marinas to provide buoys, small anchors and chains from which these devices could be suspended in the water, and then get local citizens to assist in retrieving the devices, and downloading data as needed. So, each of these devices, the wet chemistry is stable for about a month and a half, and then we would come in and exchange the wet chemistry cartridges for them to, but more, at a higher frequency than that, I would envision local folks taking these devices, pulling them up, downloading the data, and on a more, on a shorter time scale.
Are folks like Doug sitting on his porch, and if he had a laptop computer and he's sort of got your coordinates, could he gather data from, do you emanate?
No, we would love, that would be a lot more money. We would love to have things be networked such that the data could be, we'd love to have the data be telemetry, but it's not. You have to go to the device, and it's a USB download directly from the device.
So Doug, you've listened to George now for almost an hour. Give us your critique of him.
I'd rather give my critique of you. Well,
Doug, by the way, for many years was on the board of the Robert Jackson Center, chairman of the board of the Robert Jackson Center, and so I got critiqued quite a bit, so they don't know what.
This is the first time I've heard him. I've been around him for a long time, and I'm a scientist, right? Now, what am I doing talking about Bob Jackson? He just happened to be my grandfather's lawyer. But the bottom line is, this is the first time I've gotten Greg to talk about science, so I have a special prize for him. Anyway, I think the situation very simply is that you apply the best scientific and scientists to get the best scientific information you can about a problem that's as vexing as this one. We have problems with green algae now, but we've been finding Asian carp in the Maumee River in Toledo. So, other things are coming, and we've seen what happened with zebra mussels, and in Lake Michigan, we saw what happened with alewives. These are things brought from other places that caused all sorts of just incredible difficulties for citizens living on those lakes. I'm hoping here, because the lake is relatively small, that with the approach of a scientist's approach to study the problems, that will, number one, find out what we can do to remediate them, and number two, we'll find out something that maybe somebody else can use in their remediation of this technology. And I can't think of anybody or any group. This is not one single individual. This is 8 research scientists, just like George, applying their own particular areas of skill and interest to the problems that result from green algae and other things. So that's my critique, is that if you're going to approach a scientific problem, you need scientists to do it. And here's one that will be very, very helpful for us.
George, you traveled the furthest. I'm going to give you the final word on our event. So what's the Walkaway today? You're in the middle of a huge project in Lake Erie. You've got enough funding. I'm sure you feel the pressure of getting the funding and getting results. You, through collaboration or jawboning with Professor Neckers, you've now launching a pilot project here in Chautauqua Lake. What's kind of the walkaway you'd like all of us to have today?
I think that all problems of this scale in Chautauqua Lake do have a solution. We just have to decide what the best solution is. And we need to bring as much science to bear to understand everything we can about the lake. And we have resources that can make a fair number of sophisticated measurements. And then, but I want to, I said it before, we are a resource. We're not the experts on the lake, the people who live here are. And so they're part of this in helping us do this, and they are key in the decision making as to what happens to the lake in the future.
Ladies and gentlemen, Doctors Neckers and Bullerjahn, who are relatives.